Hey everybody, welcome back to Everything's a Project. So today's project is a intercooler fan plate. They're going to have 3 of these high-speed fans blowing down into the intercooler on some type of a race car. So the customer made a rough template, based off of the vehicle parameters. So this area is where it's going to get bolted to the car, and that's to clear something. And then he eyed up, how they're going to be. So I measured what they're going to be. He's indicating he wants some weight reduction holes. So what I did is I take that and I come up with this. I use Corel Draw. I've used that for, I guess it would be about 30 years this year. It's come a long ways. It does dimensioning now, where before it didn't. Used to be just for drawing, graphics. In the military it was real popular for the emblems. Like, I think it was version 7. You bought version 7. You got every military insignia and emblem ever made because the government was using it. Great when I was in the military and making awards and stuff like that, but not so great probably if you're of nefarious means. So none of that's included anymore. Used to come with 1,000 fonts, so you could do all kinds of stuff. But anyways, so what I do is I draw it out, map it out. If I had my CNC mill going, then it would be great. I could do these as cool shaped pockets following the curve of the holes, but I don't. So my compromise, and customer bought off on it, is a series of holes. So the smaller ones are 1/2 inch, 1 inch, 3/4, and then the black holes are the bolt locations, and they'll use metric. And then what I do is I do 0, 0 is my center. And then that way all these, because it's a symmetrical panel for the most part, the only thing that's not symmetrical is these bolt locations. So you can see all these numbers, and these are all plus and minus. So go this way and go that way with all these numbers. And then these are the ones that are a little more specific. And then also doing in, this would be the Y direction once it's on the mill. So I draw this to full size. So this is 25-inch long, 6-inch wide. So if I had a plotter, it'd be a big piece of paper. But what I do is I draw it up to scale, so that I don't have to worry about doing any math when I type in the numbers. If it's like this hole is 5.5-inch 650, I make a circle 5-inch 650. When I get it all done, I save a raw copy. Then I do a function where I select everything and I disassociate the numbers from there. Because if I left it all together and then shrunk it to fit on this piece of paper, all these numbers would start adjusting. But if I disassociate them, then I can shrink the whole thing down so it would fit on a 8.5 by 11 piece of paper and retain the original dimensions. Obviously this is not a 5.6-inch hole, but the numbers still correlate properly. So then I've done plate stuff a time or two in the past, and again the CNC mill would be good for it. But on Amazon I always keep a running want list, and the Evolution saw has always been on there. This is the smaller one. This is the 7 1/4 blade one. So it just came today from Amazon, and it's on sale. It's at $83. Today is, so if you watch this a year from now and say, hey, it's not on sale, it is Sunday, May 19th, 2024. But yeah, they're on sale for like $84. 7 1/4 blade. It's multi material, so mild steel, aluminum, wood, and tubing, plastic. So I've done one cut. It was in the box a half an hour ago. Did one cut. It does, they're kind of shards. I can't twist my hand. I don't know if you can make that out, but so they're kind of shards that they do. So the first time I did it, I didn't have the vacuum on. It doesn't exactly fit the vacuum hose that I have, but once I turn the vacuum on, it'll suck itself anyways. So hopefully this cut goes well. The first cut went well. It's fairly clean. It's not perfect, but it's file would clean it up pretty good, or a quick pass with that mill. So I'm leaving a little extra material, of course, and the original cuts are square. So this is my reference corner, and so I cut this end, the far end, and I'm going to cut the inboard end. So hopefully I do this because I also want to catch the drop and the vacuum hose on there, and I'm going to have my safety stuff on. So let's see how it goes. So I wore a dust mask the first time, just in case it was more powdery, but it's not, it's more chips. So I'm going to skip that this time, and then that way you can hear me too. So eyes, ears, my lovely vacuum with the remote. Best thing ever. Get your vacuum cleaner, put on one of those remote outlets. On, off. Very nice. So we'll just set that inside the fitting. Let's see if it stays pretty good. If it falls off, it falls off. Here we go. Okay. Whew. So those shards kind of suck. The first cut that I did was a shorter length, so I didn't really run into that middle area where it really was throwing around the shards. So, face shield next time. The shards, they're not really hot, but they're kind of like your C's and 6s, so they got a little bite to them when they hit you. So I got a couple like on the nose and stuff. The vacuum was doing okay. Eventually the hose did fall off. Point you down. So over there is the bulk of the chips from the first time, that the shortcut. So there's about as many chips this time as there was a shortcut, so the vacuum took some of them. Okay, so the next thing is going to be is I got to square up the mill, because I had canted the head when I did that shaft project, and then I'm going to square up the material, clean it up, get it to size, and then I bought a 5.5 inch hole saw. So I'll knock out the 3 holes, and then with the boring head I'll set that up for the final dimension. That'll do that, and then I'll go through the series of lightning holes and the bolt holes. I have to do a test pattern on the bolt holes just to be safe, because when you have a 3 bolt pattern, it's hard to get a good read on it, but And then this is also not symmetrical. So these two are technically close to each other. So I used a protractor and I put the pivot point of the protractor at this one, and then I read that one and that one. Essentially it was 70 and 110, so 180. So, and that's how I drew it out. And then I'll spot check it and then on a piece of scrap, and then I will adjust if I need to, and then do the final version. So we'll come back after I get the mill set up and start making some drill chips. Hey, so welcome back. It's only been a few minutes since I did the cut with the Evolution saw. I wanted to mention a couple things. So this is Velcro in a roll, bulk roll, and it's the fuzzy side on one and the hooks on the other side. It's not two different pieces. It is awesome stuff to have for like your cords on your tools. Like the cord on this saw is very long. It's probably 20 feet, which is going to be nice if you're cutting long pieces of material. It's very strong. You can see it's whole. You know, that's not a lot of weight with the vacuum hoses, but you can see I have it up there. Super easy to undo it. If I do on some of my tools, I'll have it so it's attached like here, so that when I unravel it, I don't have to look for where the Velcro went. It doesn't fall off the tool. So anyways, and this is available through Amazon. And I believe it's original 3M material, and it's great. You'll find a whole bunch of uses, and like I said, it is very strong. You get at least an inch or so of overlap, and it'll hold just about anything. Okay, then the other thing I wanted to mention is this is the 5/8 pattern. This is a Langmuir table, and these are Fireball Tool accessories. So that material I just cut, the first piece I did, I used these as a stop to keep my material square and secure, and then I clamped it. But what I wanted to show you is that there's a couple different combinations you can do. So on the next cut, these two weren't giving me the standoff I wanted. You know, it was either going to be too much or not enough for when I did the cut. I of course didn't want to hit the table. So what they have is they have these blocks, and you can see they're kind of staggered with how the pins are. So if you do it like that, so the pins are back here, it's the same result as the pin in the hole. So these two you could use together, they line up. If you flip it around so that the pins are different, so see the pins are, this might have been misleading, you see in the hole there. The pin is forward, that gives you the same result as just using it around. The pin is back, essentially it gives you like a half position, so it's registering off what would have been the back of this instead of the front of this. So it's splitting the distance between the two holes. So that just gives you more versatility. A lot of people don't know about that stuff. These holes are made for stacking. If you need to support something, or you got something that's going to register high. And of course you can see there is some play in this. So what you have to do is you do have to push up against it. And you don't measure off of this, but this just keeps you square. Okay, so now I'm going to go set up the mill. See you in a little while.